Hello students, how are you all? Welcome back to Akshar ID Foundation classes, and I am your chemistry faculty S. Mohan. Students under 8th class, ID Foundation, we are discussing about the periodic classification of elements, right? In the previous class, we discussed about the periodic table, how the elements are distributed in the periodic table, and we also discussed how the elements are classified in the periodic table based on the differentiating electron. So the elements in the periodic table are classified into 4 blocks like S block, P block, D block and F block. That's all we discussed, right? So today we go to some periodic properties. Okay, so let's discuss about some periodic properties. What are the periodic properties? Students, in the periodic table, we can see some properties, okay, like atomic radius, or we can say atomic size, ionization energy or ionization potential, electron affinity or electronegative character or electronegativity, electropositive character, electropositivity, metallic nature, non-metallic nature, nature of oxides. These are all things, valency, these are all things we are going to discuss in the periodic properties of the elements. Okay, but here in the 8th class, just we are going to discuss only about the 3 properties, right? In that, first property is atomic radius, and second one is ionization energy, and third one is electron affinity, right? The remaining properties, when you go to the 9th class, in the next year, we are going to discuss about the few more properties, right students? So today we are going to discuss about the atomic radius. Instead of atomic radius, if I say that atomic size, it will be very easy for you. So what do you think about the atomic size? Come on. So atomic size means what? Size of an atom. That's all, right? But okay, how can you define the size of the atom? So see students, here already in the previous classes, like in the atomic structure, we discussed that atom consists of electrons, protons and neutrons, right? In the protons and neutrons are present in the nucleus, and electrons will be revolving around the nucleus in the various orbits. This we discussed. Okay, so in that manner, if I would like to say what is meant by atomic radius, then we can say that the distance between the center of the nucleus to outermost shell means what? Valence shell of an atom is called atomic radius. Means for example, see here, I will take sodium atom. Okay, sodium atomic symbol is what? Na, right? What is its atomic number? 11. What will write the electronic configuration? 2, 8, 1, right? This is K shell, this is L shell, here it is M shell, right? So now, for example, how can we distribute the electronic configuration? So this is a nucleus, and this is the first shell called K shell, this is the second shell called L shell, this is the third shell called M shell, right? In the K shell, how many electrons are there? 2 electrons, right? So we have the 2 electrons. So we put 2 electrons here. This is 1, 2 electrons. Okay, this 2 electrons. And the second shell, 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And the third shell, 1 electron. So here, in simple way, we would like to say what is atomic radius or atomic size. So here, the distance between the center of the nucleus. So this is the center of the nucleus, right? From here to the outermost orbit. Outermost means what? Last orbit. Okay. So first orbit, second orbit, third orbit. This is called the atomic radius, right? This actually we studied in the school level, right? But actually, students, here these electrons revolving around the nucleus, like we can say that electron cloud in the higher classes. So these electron cloud will be extended up to infinity. Means what? More distance. Okay, there is not like particular orbits like this. Okay, what you study in the lower classes. Okay, so here you can see here atomic radius, the distance between the center of the nucleus and the electron cloud of the outermost, okay, level is called the atomic radius. So, center of the nucleus is what? This is the center of the nucleus, right? And the electron cloud of the outermost energy level. So, this is outermost energy level, okay. This is called atomic radius, clear, okay. That is the atomic radius, right. But the thing is that, can I find the atomic radius of any element directly by taking one atom? Is no. I cannot find the exact atomic radius by taking one individual atom, okay, directly, okay. So that what we follow some different method to calculate the atomic radius of the atom, right. So here the atomic radius cannot be determined directly. We cannot determine directly. Then how can we determine? By measuring the internuclear distance of combined atoms. Internuclear distance of combined atoms means you know that, for example, hydrogen is there, okay. So hydrogen, generally hydrogen atom, okay, does not available in the nature, okay, as it is like hydrogen atom, right. It is in the atomic form, it do not available. It's available in the form of hydrogen molecule, right. Oxygen also, normally oxygen atom is very unstable. The oxygen atom is also do not available in the nature in its free state. Then how it is available? In the form of oxygen molecule. Oxygen molecule formula is what? O2, right. So means what? Two oxygen atoms are combined, right. So like this, we take the molecule in which two atoms are combined, right, in which two atoms are combined. That's called as a molecule, okay. Now in that molecule, we can find the internuclear distance, means what? The distance between the nucleus of one atom to nucleus of the another atom. So the two atoms nucleus distance we can find and by using the X-ray diffraction method. By using what? X-ray diffraction technique, okay. So by using X-ray diffraction method or technique, we find the distance between the two nuclei of the combined atoms, okay. Then we make it into half, then that gives atomic radius of that particular atom, clear. So now for example, you see here two atoms are combined here, okay. This is one atom, okay, any atom for example, and this is combining with some other atom like this, okay, two atoms. So here it is a nucleus, this is a nucleus. Now what we do, we find the distance between the two nucleus. This is called internuclear distance. What it's called? Internuclear distance. So we find the internuclear distance, means the distance between the two nuclei of the two atoms by using X-ray diffraction techniques, and then we make it into half. So we make it into half. So this distance gives the atomic radius of that particular element. Clear to you? Okay. So this is about the atomic radius, right? Now the question arises that whether this atomic radius of all combining atoms gives the same value, means no. The atomic radius, what we measure, that's not, that's depend on different factors. That's depend on different factors. So many factors are there. Okay. So on what factors? Just we are going to discuss on what factors the atomic radius depends. Okay. And that detailedly we discuss in the next class. Means when we go to the higher class, there we can discuss. Okay. So here atomic radius depends on nature of bonding. Nature of bonding. So you know that elements will combine to form the molecule, okay, or compounds. So in that there are different types of bonds are present, right? So these bonds normally mainly three types of bonds are there, right? One is called ionic bond, second is called covalent bond, third one is called metallic bond. So ionic bond, generally ionic bond is formed between one metal and a non-metal, means one electropositive and one electronegative element, like sodium chloride. Sodium is electropositive, that's metal, and chlorine is electronegative, that is non-metal. The bond is formed. This is called an ionic bond. And covalent bond generally it forms between two non-metallic atoms, okay, like for oxygen, okay, that's covalent bond. In hydrogen molecule H2, covalent bond. Nitrogen, covalent bond. Next, water molecule H2O, covalent bond. Ammonia, NH3, covalent bond. Methane, CH4, covalent bond. Like this, between the between two non-metals, if the bond is formed, that is called a covalent bond, right? Then one more bond is there, that's called metallic bond. So the bond between two metals is called a metallic bond. So what type of bond is present between the two atoms in that molecule? So based on that, the atomic radius depends. So atomic radius depends on the nature of the bond, right? Next, number of bonds between two atoms. How many number of bonds are there? For example, if you take hydrogen, so hydrogen molecule between two hydrogen atoms, there is a single bond. There is a single bond. If you take the oxygen molecule, between two oxygen atoms, there is a double bond. Two covalent bonds are there. And if you take the nitrogen atom, between two nitrogen atoms in a nitrogen molecule, there is a triple bond. So how many bonds are there? Depending, that also, okay, play the important role. And oxidation state means what? Oxidation number. Next, coordination number of an atom. One atom is combining with the how many other atoms? That's called coordination number. And bond character. So these all are the factors on which atomic radius depends. Okay. So these are the factors. Only you need to remember the factors as you are in 8th class. Okay. If you go to the 9th class, in the higher classes, we discuss how each and every factor affect the atomic radius, that we discuss in detail, right? Okay. Is this clear till here? Any doubt? So once again, see here, atomic radius. Atomic radius means what? The distance between the center of the nucleus and the outermost means what? Last, okay? Electron cloud or outermost energy level is called the atomic radius. Atomic radius of any atom cannot be determined directly, okay? It can be determined by using the X-ray diffraction method, okay? That too by finding the internuclear distance, right? And this atomic radius depends on some factors, that is nature of bond, number of bonds, oxidation state, coordination number, and bond characters, right? Chalo, no doubt. We'll go to the next one. Now, there are how many types of atomic radius we can find? So there are mainly 3 types of atomic radius are there, right? So as I just now I discussed that is depending on the bonds, okay? So here 3 types of atomic radius, okay, we can find. One is called a crystalline radius or metallic radius. Here metallic radius means what? Here we can take the 2 metal atoms which are combined together. Then we can find the internuclear distance between the 2 metal atoms. So here both the atoms are metals only. Then we find the internuclear distance between the 2 metals. Then we make into half. So that gives the atomic radius of the metal atom. Okay. So for example, this is one metal atom. This is one metal atom. Both are combining like this. Both are joining here. Okay. And we can find the internuclear distance between them. Okay. And make it into half. That gives the metallic. Van der Waals radius. Van der Waals radius means what? Where there is a weak force of attraction. Van der Waals radius is considered a weak force of attraction. Okay. So between the 2 molecules, there is some weak force of attraction is there. So due to that term, then we can find this weak force of attraction means what? They are not very close to each other. They are far from each other. Okay. In such case, we can radius is called Van der Waals radius. Covalent radius. Covalent means what? Here 2 atoms will combine like this. How? So like this. So see here, these both are mixed here. Can you see here? Both are combined like this. Okay. So here this is nucleus, and we can find the internuclear distance and make it into half. That is called the covalent radius. Okay. So covalent radius is what? The internuclear distance between 2 atoms bonded by covalent bond. Right. So these are the 3 types of atomic radius for that. Right. Now in this generally you see here the atomic radius which is calculated by the covalent radius value will be lesser. Remember, very important point, lesser than the metallic radius than the Van der Waals radius. Means what? When you calculate the Van der Waals radius, okay, you will get the little atomic radius value will be little more than the metallic radius than the covalent radius. Okay. Why? So because here I said no, Van der Waals radius means what? Weak force of attraction. Metallic bond almost there in contact. Okay. And where is the covalent radius? See, they are both are intermixing here. Okay, so the atomic radius here, the covalent radius will be lesser than metallic than the van der Waals. Is this clear? Now, then come to the how can we measure the means there should be some unit. Generally, if you want to measure any distance, the SI unit of the distance is what? Meters. You might have studied in the physics, right? So then how can we measure the atomic radius in meters? Means actually distance is measured in terms of meters only, right? But the thing is that here atoms are very small. We can't see the atoms with our naked eye. Can you see by using the microscope? No. Even with the normal microscope also we cannot see the atoms. Then we can see the atoms with very high powerful electronic microscopes we use. Such as small distances, how can you measure in terms of meters? So we cannot measure in the meters, but we use a unit called the angstrom or nanometers. What we use? Angstrom or nanometers. Angstrom is what? 10 to the power of minus 8 centimeters is called angstrom, or 10 to the power of minus 10 meters is called angstrom. So here 1 angstrom value is 10 to the power of minus 8 centimeters, or you can write 10 to the power of minus 10 meters. Like this also you can write. Or nanometers. Nanometer is what? 10 to the power of minus 9 meters. This is called nanometers. What are picometers? 10 to the power of minus 12 is called the picometers. Okay. So in this way we can measure the atomic radius. Atomic radius can be measured in angstrom units or nanometers or picometers. Okay. So that's about the atomic radius. Okay. Now the question rises that whether the atomic radius of all the elements in the periodic table is same. Just guess. We have 118 elements in the periodic table, right? All the atomic radius of all these elements remain same? No. Yes or no? For example, you see, you are in the class, in your 8th class, for example, imagine there are 25 students over there. Does the 25 students all are 8th class only, right? All the height remains same? No. Yes or no? So here also, atomic radius of all the elements do not remain same. Is there any pattern in the atomic radius in the element of the elements in the periodic table? Yes. Okay. There is some pattern we can observe in the atomic radius of the elements in the periodic table, right? So how it changes? So when you see, already we discussed the periodic table, right? In the periodic table, as we move from left to right, they are called periods. What they are called? Periods. Already we discussed. And as we move from top to the bottom, are called groups. Okay. Horizontal rows are called periods. Vertical columns are called groups, right? So in a period, okay. So in a period, the meaning is what? As we move from left to right, then atomic radius decreases. Atomic radius decreases. Okay. For example, let us take second period elements. So what are the second period elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So no, we don't consider the neon, that is an inert gas. Okay, that we discuss later. Okay, but now there is a period. Now there is atomic number 3, atomic number 4, atomic number 5, 6, 7, 8, 9, 10. Right. So as we move from left to right, atomic radius decreases. What happens? Atomic radius decreases. Okay. The meaning is what? Lithium is a bigger element. Okay. And when we come to the beryllium, it is little smaller. Okay. Now similarly, beryllium to boron. Actually, there are some exceptions over there. These exceptions we are going to discuss in the higher classes. Okay. Now in general way we are discussing as you are in 8th class, right? So as you are moving from left to right, atomic radius decrease. That you remember. Okay. So lithium to beryllium is smaller. Beryl to boron, there is a change there that we discuss later. So boron to carbon decreases, carbon to nitrogen decreases. Okay. So like this, as you are moving from left to right, atomic radius decreases. Okay. So lithium is a bigger one. Means alkali metals are the bigger in size, and as we move from left to right, atomic radius will be decreases. Okay. Sure. Now why? If they ask question why the atomic radius decreases as we move from left to right? So students, here if you write the electronic configuration, here electrons are being added to the same shell. Means what? Here for example 3 is there, so we write the electronic configuration 2, 1. Okay, this is K shell, this is L shell. Here beryllium 2, 2, boron 2, 3, carbon 2, 4, nitrogen 2, 5, oxygen 2, 6, fluorine 2, 7, neon 2, 8. So here the second shell is L shell. Okay, so electrons are being added to the same shell, right? So in the L shell, 1 electron, L shell 2 electrons, L shell 3 electrons, L shell 4 electrons. So electrons are being added to the same shell. Okay, so due to that, what happens? The nuclear force of attraction over the electrons will be increases. You know that nucleus has a positive charge, and as atomic number increases, nuclear charge also increases, means number of protons also increases. So the force of attraction of the nucleus over that electrons will be increases. So they pull the electrons little more stronger. Okay, so due to that, the atomic size will be decreases. So as we move from left to right, atomic radius decreases. Clear? Sure. Now in a group, what happens? What is a group? In a group, what happens in the group? Group means what? Vertical column. As you are moving from top to the bottom in a vertical column, atomic radius increases. Why? Let us know. See here students, here first group elements I will take. First group elements are what? Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So these are the first group elements, right? So these are the first group elements. Okay. Now in this first group elements, hydrogen atomic number is 1. I'll write here. Hydrogen atomic number is 1. So electronic configuration, see here, K shell, L shell, M shell, N shell, like this will be there. So we write 1, right? Now if you take the second element, lithium, so 3. So what we can write? 2 and 1. Next is sodium, what? 11. So what do we write? 2, 8, 1. Next to potassium, what is that? 19. 2, 8, 8, 1. So here hydrogen has only one shell, K shell. Hydrogen has only one shell, K shell. This is K shell. But if you go to the lithium, 2 shells are there, 2 and 1, L shell. So this is the K shell, L shell. So one extra shell is there. So this is bigger, right? Sodium has 3 shells, 1, 2, 3. So sodium cells will be 1 shell, 2 shell, 3 shell. It's a little bigger. So as we are moving from top to the bottom, one extra shell will be added to every next element. So due to that, atomic radius will be increases. Okay. So students, very simple. As you are moving from left to right in a period, atomic radius decreases. As we move from top to the bottom, atomic radius increases. Clear? Right? So that is about the atomic radius. Chalo, here it is given once again. So in a period, see, in a period from left to right, atomic radius decreases. Why? Because nuclear charge. Okay, nuclear force of attraction over the increases. Okay. So see a variation is given. Now similarly in a group, you see, as we move from left to right across the okay, this particular, now variation in the this is there. So here just want to learn, a given period the alkyl metal is the largest and halogen is the smallest one. Alkyl metal is not first group elements. Okay, the atomic size of first group elements is greater and halogen is smaller. Okay. Right, and now in the variation groups, here in a group from top to bottom, the atomic radius increases. Why? Due to addition of one extra shell. Okay, so due to increase in the number of orbits. Okay, so one extra shell will be, number of orbits will be increases. So due to that, atomic radius decreases. Now if I say the first group elements, hydrogen is the least among all the elements and the highest is the cesium. Okay, I told you. See, hydrogen is the least and cesium is the highest. Okay, so that's all students. So this is about the atomic radius. So with this we completed the synopsis too, right? Now, okay, now let us see some questions. So practice sheet open, if you have a practice sheet. So these are the questions of that. So see now, the distance between the center of the nucleus and the outermost electron cloud is called the atomic radius. So the option is 1. Correct? You say the answers, very simple answers this one. Okay, you can say the answers, just I will take later. Now, half the internuclear distance between the adjacent atoms of metal crystals, here metal crystals is called crystal radius. Metal crystals, so crystal radius. Next one is also similar way. Half the internuclear distance between the atomic different molecules when they come close to van der Waals attraction of forces. What is that? Van der Waals radius. So this is a van der Waals radius, right? So the option is 3. Now, half the internuclear distance between the two atoms held together by the covalent bond. What it is called? The covalent radius. Okay. Option is 4. Right? Any doubt till here? Easy, no? Very easy. Now then go to the next one. The van der Waals radius. Van der Waals radius. That's what I told you. Van der Waals radius. I differentiated. Okay. Van der Waals radius is larger. Okay. Among all this one. Right? Because the weak forces of attraction exist between the two molecules. Okay. The unit used to measure the atomic radius. We discussed this now. That's angstrom units. No. So answer is 1. Angstrom. It is given by 8 to the power of 0. Screening constant represented by, okay, this is a previous topic we discussed, so that is sigma. So answer is this one. The magnitude of sigma is denoted by, this is not given, but okay, remember that is Snell's rule. Okay. Next one, the order of decreasing effect of electrons in various orbital, that is scaling effect. Scaling effect will be less in the s orbital, then the p orbital, then the d orbital. Second option is the right answer. Okay, the scaling option is very less in the SPDF. Okay, the scaling effect in the d electron. D electron means here it is very less than the much more than equal to p. So that's much less than the here. Okay, scaling effect. Scaling effect of the electron is much more. This is right answer. So this is wrong answer. This one. Okay. So scaling effect here in this option, F is greater than D is greater than P is greater than S. So D is greater than S. So much more than the S electron. Okay. So that's all, students. So with this we completed the synopsis 2 of a periodic classification of elements, right? So students, very important topic, very easy also, and this I already told you that periodic classification is very important in the chemistry. If you know perfectly the periodic table, then the meaning is what? You know about all the elements and their periodic properties, their physical and chemical properties also you will come to know. So the meaning is about half of the chemistry is done. Okay. So students, with this we stop, and until bye.